बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन। Differential equations. Lecture 1. For this lecture, I am using the work of one of my best student, Miss Sayyida Fiza Kaisar of class 2020, the Lyceum. Comprehensive concepts are essential to be good at any topic or subject. What is a differential equation? An equation that has a derivative such as dy upon dx or d2y over dx2 as one of its terms is called a differential equation. When the equation has the first derivative dy upon dx as one of its terms, it is called a first order differential equation. For example, the equation dy upon dx is equal to 3x square is an alternative way of representing the relationship y is equal to x cube plus c, where c is a constant. To solve a differential equation, we integrate to find the direct relationship between x and y, such as y is equal to x cube plus c. The direct equation y is equal to x cube plus c is called the general solution of the differential equation. To find a particular solution, we must have further information that will enable us to find the value of c. The technique of separating the variables. How do we solve the differential equation? dy upon dx is equal to xy when y is positive. We cannot integrate both sides with respect to x and find a solution. Separating the variables in the expression xy means that we are then able to integrate. Separate the variables x and y. Write x with dx and y with dy. We always shift this operator on right hand side. So by shifting dx on right hand side and bringing y on left hand side, we have 1 upon y times dy is equal to x times dx. This is the variable separable. Integrate each side. This is the general solution of this differential equation, where c is the constant of integration which is written on one side, that is right hand side, to make the calculation simple. This is the general solution as we don't know the value of the constant c. When we have further information, we can find the particular solution of the differential equation given by that information. For example, we have this equation dy upon dx is equal to xy given that y is 2 and x is 0. With the help of this information, we can find the particular solution. Well, after the variable separable and integrating on both sides, we have this equation ln y x square upon 2 plus c. Using this information, we can get the value of c. By substituting the value of c over here, we have this equation. Now bring this ln on left hand side so that we can express these two ln's as a single ln form, and then we can easily make the y subject. This is the particular solution of the differential equation. Note, you often need to write your answer as an expression of y in terms of x. This commonly means using laws of indices or logarithms. Question number 2. The most important thing of the differential equation is the correct variable separable. Well, first you need to bring this entire thing onto left hand side, and you have to shift dx and x on right hand side. So let me show this variable separable here. So y upon y square plus 4 dy dx upon x, or 1 upon x times dx. This is the variable separable. And make sure you do this step carefully. And after the variable separable, you just need to take in sign of integral on both sides. and then you can integrate both the sides. This is the application of basic formula number 2. The differential of this function is 2y. So 2 is missing over here. So this will become ln modulus y square plus 4 over 2. This is just ln x plus c. This is the general solution of this differential equation. Example 3. By using the rules of indices and this rule of indices over here, we can split this power. E power x plus y can be written as e power x times e power y. And after that, we need to go for the separable. We need to do the separable. So by bringing this e power y onto left hand side, we have e power minus y dy, and dx is here. So ex dx. Let me show this step here. Dy upon e power y dx. And then we need to bring e power y into numerator. So this will become e power minus y. And then we just need to take sign of integral on both the sides. The integral of e power minus y is e minus y over minus 1. E power x, the integral is e power x and plus c. This is the general solution of this differential equation. Example 4. d theta upon dt is proportional to theta minus a. Since when y is proportional to x, we write y is equal to kx. Therefore, d theta upon dt can be written as equals k theta minus a. We have to remove sign of proportionality by writing constant. And then we have to do the separable. We need to bring theta minus a onto left hand side, and we need to bring this dt onto right hand side. And then we need to take sign of integral on both the sides. The integral of this is ln theta minus a. This is kt plus c. Over here, we have fraction. Make sure when you do separable, you need to eliminate the fraction of coefficients. So we need to bring this 3 on left hand side so that we can eliminate this fraction to make the integration simple. So remember, always eliminate the fraction of coefficient so that you can integrate the things easily. So by bringing 3 over here and r square on left hand side, we have 3 upon r square, and by bringing dt on right hand side, we have 4 times dt, and then you can easily integrate this. Well, this coefficient is not in fractional form, so don't disturb the coefficient if coefficient is not in fractional form. Leave the coefficient 0.06 as it is on the right hand side of the equation since it is not in the fractional form. Just bring v plus 3 on to left hand side. So finally, after the separable, we have dv upon v plus 3. 0.06 is as it is here, 1 upon t and dt. After taking sign of integral on both sides, we have ln v plus 3 here, 0.06 here, ln t plus c. Now we have to bring this 0.06 on to left hand side because this is in fractional form. So by bringing this onto right hand side with v plus, or onto left hand side with v plus 3, we have 0.06 over 1 upon 1 v plus 3 dv, and this t upon dt will become 1 upon t dt, and this is the general solution. Finding a differential equation from a problem. This is very important. The key to forming a differential equation from a problem is the successful interpretation of the language used in the question. This is very important. You need to go through the question very carefully. For example, when you are given problems such as The rate of increase of the number of bacteria in a dish is k times the number of bacteria in the dish. The number of bacteria present in the dish at time t is x. Answer. Replacing the words the number of bacteria in a dish by x, the problem becomes the rate of increase of x is k times x. Therefore, dx upon dt is kx. The rate of increase of x means dx upon dt is k times x means is equal to kx. The following techniques will help you to prove the differential equations. Chain rule. It is used for three variable relations. You know the chain rule. You have done this in A1. Y, y, x, t, x, t. For example, given dv upon dt is 16 centimeter cube over per second and dv upon dh is 4 upon 9 pi h square, find the expression for dh upon dt. Since one rate is given and the other rate is required, therefore use chain rule. And the chain rule will be VVH THT. So this is the chain rule. By substituting the values into this chain rule formula, we can have dH upon dt. And then we have to go for variable separable. We need to bring pi h square on left hand side and we need to bring dt on the right hand side. And then we can easily integrate this. This is the general solution of this differential equation. The second point is net rate of volume, for example. It is the inflow rate minus outflow rate, or net rate can be written as rate of formation minus rate of removal. Similar objects. For similar objects, use the ratio of their corresponding sides. This will help you to prove the differential equation. Well, we can write h upon 10 and r upon 6. And from this relation, we can make either h or r subject, whatever is required. Well, since this is right angle triangle, so also using tan theta in the right angle triangle, we can get the relationship of r and h. Sketches. Exponential functions. Exponential with negative power. This is very important. We must have exponential with negative power in this chapter. So make sure whenever you make y subject after solving the differential equation, make sure you make y subject in this way. You must have negative power of exponential on right hand side. This will I will explain while solving the questions of differential equations, inshallah. Well, this is the sketch of this exponential function. So when t will tend to infinite, when t tends to infinite, this negative power of exponential will tend to 0. Therefore, this y will tend to 0. See, according to this sketch, when t tends to infinite, the exponential tends to 0. Therefore, y tends to 0. Y will always tend to this number. Like this, y will tend to 5. State what happens to the value of y when t becomes very large. So in this equation, when t tends to infinite, then exponential will tend to 0. Therefore, y will tend to this number. You can directly write y will tend to 0. Y will tend to 5. When t tends to infinite, e power minus t will tend to 0. Therefore, y will tend to this number. Integration. Important examples of integration which would help you to solve the differential equations. In this example, you know you have to use by parts because we have product of different functions, and you know how to use by parts. I'm not going to explain this over here. You already have done this in integration. Well, this is the even power of sine. So you know how to integrate even power of sine. We always use double angle formula to solve the even power of sine and cos. So make sure you will write 6 over here. The angle must be double. This is the double angle. And the rest is simple. The integral of 1 will be x and the integral of cos will be sine 6x. You know how to integrate the odd power of sine and cos. We first split the power into 1 and then remaining power. Then we use the identity and then we go for the simplification and then finally we can integrate this. Sine 3x will become minus cos 3x, and this is the application of the basic formula 1. The differential of cos, let me clear this power. This is, give me just 1 minute. This is cos 3x power 2. So the differential of cos 3x is negative sine 3x times 3 minus 3 sine 3x. So in this differential, minus 3 is missing. So add 1 in power, divide the function by the resultant power, and multiply this resultant power with the missing differential. This is the way we integrate sine cube. Well, this is the application of basic formula 1, whereas this is the application of basic formula 2, because the power of the function is 1. So we need to bring this expression, this function in the numerator like this, and here we just need to use the basic formula 2. So the integration of 1 minus 3x power minus 2 will become 1 minus 3x power minus 1 minus 3 minus 1. Minus 1 is for the differential, resultant power. And this is the differential of this denominator is 6x. So 6 is missing. Leave this 5 as it is here. So ln 2 plus 3x square over 6. Make sure you use modulus with ln. Here, this is an improper fraction. So the best way to solve this question is use long division method. Don't use partial fraction. Let me remove this method. Always use a long division whenever we have improper fraction in integration with just one factor in denominator. See, this is just one factor. So go for long division and then use remainder theorem to split the fraction, and then you can easily integrate this. This is also an improper fraction, but here we can break the LCM. So by breaking the LCM, we have this, and we can easily integrate this. And make sure you use modulus with ln. Again, we have improper fraction. An improper fraction with one factor in denominator, go for the long division and then use remainder theorem to split this fraction into partial fraction, and then you can easily integrate this. an improper fraction, but here we can break the LCM. So always break the LCM whenever we have just one term in the denominator. We can always go for the breaking the LCM, and we always break the LCM in fact. So by breaking the LCM we have this thing. So finally we have this result. This question is very important. First simplify this numerator and then break the LCM. You all know how to integrate tan 3x. We can write tan as sine 3x over cos 3x. This is the application of basic formula 2. The differential of cos 3x is negative 3 sine 3x. So negative 3 is missing, which is here. And this is modulus. Because ln is only defined for positive values. We can write cot as cos 3x over sine 3x, and you know the differential of sine 3x is 3 cos 3x, so 3 is missing, so ln sine 3x over 3. And this is the question of the substitution. Substitution is given, x is equal to 2 sine theta. So you know how to solve these type of questions. First differentiate x to get dx, change the limits, and you know how to integrate sine squared theta. Well, this is all. Inshallah, I will discuss the solutions of important questions of differential equations in my next lecture, inshallah. I hope this lecture will help you all to understand the concepts of differential equation. Be of benefit to others. This is an important advice for me and for everyone. Allah Hafiz.